Okay, I think that this video shows you an example of something that is generally pretty challenging for students on the test. Okay, so we want to really focus on this, and I would say if there's an assignment that you want to make sure you really check your answers and really make sure you know well, it's going to be this assignment. So um, we're going to spend 2 days on this. You'll have a lot of work time tomorrow, not much work time today. So log base A of A times B, we are looking at laws of logarithms, and there's certain ways that we could rewrite them. This is very helpful in calculus, and probably the main point in which we learned this. So log base A of A times B, we can separate it to log base A of A plus log base A of B. Now, when I was your age, nobody ever explained to me what that meant or why it worked out. So I'll kind of share with you why this works out the way that it does. Okay? Logarithms solve for exponents. For example, log base 2 of 32 is what? 5. So logarithms give you exponents. Okay? So as you look at this situation, this is like saying x squared times x to the third is x to the 2 plus 3, right? So exponents, when you're multiplying things of two common bases together, you can add them together. That's kind of what this is, stating. It's rewriting it in a logarithmic format. So it's bringing to light that property. We've always known how to do that, right? Well, this is what that looks like in logarithmic form. So if it's division, we simply just move it to subtraction. So log base A of A minus log base A of B. So again, that would say we had x to the 7th over x to the 4th. That would be x to the 7 minus 4. Again, you can subtract the exponents. And log base A of A to the C, if you had x to the 6th to the 3rd power, what's x to the 6th to the 3rd? X to the 18th, that would be x to the 6 times 3. You would multiply that. So you could take that exponent and multiply it. So C times the log base A of A. And those are your 3 logarithmic formulas that you need to kind of commit to memory. You can separate multiplication into addition, separate division into subtraction, and separate powers into multiplication. Hi there. We missed you. We're just very excited to see you. No, you're fine. All right. So it says, use the law of logarithms to rewrite the expression in a form with no logarithm of a product, of a quotient, of a root, or of a power. We don't want to see any of those. Right now we have a product. How can I rewrite this so it's not a product? Very good. Log of 5 plus log of 3. So instead of having one logarithm, I now have 2. Okay? Sometimes it's advantageous for us to separate them. Sometimes it's advantageous for us to put them together. And we'll do both in these examples. Okay? This example here. Which 2 rules do I want to use in order to separate these? I have rule 1, rule 2, and rule 3. 1 and 3, right? So which do you think I do first? Do I do rule 1 first or rule 3 first? Now we do 1 first, but people kind of wonder why. This is the mathematical way to understand. I'm not saying it makes it easy to understand, but here's what you want to think about. As you look at the order of operations here, what would you do first as you were to simplify this? Would you multiply the 3 and the 4, or would you square the 4? What would you do first? You'd square the 4, then you'd take 5 to the 6. And the very last thing you would do would be to multiply it together, right? Order of operations, the last thing you would do would be to multiply it together. So that's the first thing that you undo. So we undo the multiplication. So we write as log of 3 plus log of 4 squared plus log of 5 to the 6th. So we are undoing the very last step of order of operations. Now that I've done that, what can I do with the 2 and the 6? I could just drop them right in front there. So I now have log of 3 plus 2 log of 4 plus 6 log of 5. Why don't you see if you can do C on your own? Take a minute and a half here, see if you can do C on your own. Go. Okay, these are your two options. Okay. Notice that the 4 and the 7 are being taken to the third power. So therefore, the 3 must be applied to both of them. Whether it's 3 times the quantity, log of 4 minus log of 7, or 3 log of 4 minus 3 log of 7, these are your two options to write, and either one you would give credit for on the test. So again, in terms of order of operations, what would be your would you do 4 divided by 7 first, or would you do 4 to the third first? You 4 divided by 7 first, and then take it to the third last. So that 3 is the first thing you need to undo, and so you move it out front. Okay. Here, square root. How can I rewrite the square root as a power? Log base 3 of, yep, x squared minus 5 to the 1/2. So you can see in order of operations, the last thing you would do would be to take that to the 1/2 power. So that's the first thing you will undo by moving the 1/2 out front. Now, what's the last thing I do? Do I square first, or do I subtract 5 first? I square first, right? So the last thing I do is subtract 5. Is there a law for getting rid of subtraction, or separating subtraction? No, there isn't. So this is done. You can't simplify this anymore. That's it. Okay, what's the last step to simplifying 2x to the fourth divided by x minus 2 to the third? Is your last step subtraction, multiplication, division, exponents? What's your last step? Division. You would take x to the fourth and multiply it by 2. You would take x minus 2 and take it to the third. And then the very last thing you would do is take the top divided by the bottom. So since that's the very last thing that you do, that's the first thing that you undo. You guys have been doing this all along. You just have never realized it. I mean, if I've got 2x minus 3 equals 11, you don't even think about it. But what do you move first, the minus 3 or the 2? To the minus 3. Why? Because that's the last thing you do in order of operations. You take 2 times whatever, and then you would subtract. So that's what you do. And you never had to think about it before, but some students in the school, they really have to think about why they do that. So this is what we're doing. Last step was that. Okay, then do I separate the multiplication, or do I separate the exponent? Think about the order of operation. You would take x to the fourth and then multiply it by 2. So because that's the last thing you do, you separate the multiplication. So you got natural log of 2 plus the natural log of x to the fourth minus the natural log of x minus 2 to the third. Can I simplify something else? What? Yep, this needs to move there, and that needs to move there. So I have the natural log of 2 plus 4 natural log of x minus 3 natural log of x minus 2. And there's no rule that tells me how to separate that subtraction piece, so I'm done. This one, I've got an exponent. What's my exponent here? Natural log of 4x squared over 2yz to the what power? 1/3. What's my first step? 1/3 out front. So 1/3 natural log of 4x squared over 2yz. Now, do I separate the multiplication, the exponents, or the division? The division. So I have 1/3 times the natural log of 4x squared minus the natural log of 2yz. Now look at the 4x squared. Should I separate the powers or the multiplication? Multiplication. So I have 1/3 times the natural log of 4 plus the natural log of x squared minus natural log of 2yz. Now what? Move the squared right there. 1/3 natural log of 4 plus 2 natural log of x minus, I can separate that all right. So is it going to be minus natural log of 2 minus natural log of y minus natural log of z? Or will it be minus natural log of 2 plus natural log of y plus natural log of z? Which one will it be? Will it be all subtraction or addition? Will it be all subtraction. Natural log of 2 minus natural log of y minus natural log of z. Think about it. Logarithms solve for exponents. Is the z in the numerator or the denominator? Denominator. So should it have a negative exponent value or a positive exponent value? If something's in the denominator, does it have a negative exponent value or a positive exponent value? Negative. So look, negative. Y in the denominator, negative. 2 in the denominator, negative. X, numerator, positive. 4, numerator, positive. See how those coincide? You'll be able to match it up all the way through. Okay, so flip it over. What if we wanted to take those problems and do the opposite? Instead of expand them, what if we wanted to contract and put them together and write them as a single logarithm? So right now you see 2 logarithms. I want 1 logarithm. You see how I could take log base 2 of 5 plus log base 2 of 7 and write it as 1 logarithm? Log base 2 of, yep. B is a little bit trickier. I'm going to rewrite it to be 2 log base 5 of 3 minus 1/3 log base 5 of 64. Where did I get the 1/3 from? Dividing by 3 is the same as multiplying by 1/3. So what should I do? What is 3 squared? So I have log base 5 of 9 minus 64 to the 1/3. So with F rhymes with 4. Good. Log base 5 of 4. Now what? Good. Now write as division. Log base 5 of 9 divided by 4. Raylan, what do you want to major in? So it could be math. We'd possibly take calculus next year. Okay, all right, you're done. Math career is over with Mr. Gens. I will be the pinnacle of your mathematical career. Brings such joy to my life. All right. All right, what should we do with letter C? What do we do here? Move the 2 up here, the 3 up there, the 1/2 up here. So what's 4 squared? So I have the natural log of 16 minus natural log of 8 plus the natural log of, how do you write 2 to the 1/2? Now, the natural log of 16, is that positive or negative? Positive. So will it be in the numerator or the denominator? Numerator. Natural log of 8, is that positive or negative? So it will be in the denominator. Natural log of square root of 2, positive, so it will be in the numerator. So as you rewrite this, you have division here, but you have multiplication here. A lot of people might write this as natural log of 16 over 8 roots of 2. This stays in the numerator. It's positive. Okay? It's 16 times the 2, or square root of 2. So you need to write it like this. 16 roots of 2 over 8. Because you could take this expression, rewrite it as natural log of 16 plus natural log of square root of 2 minus natural log of 8. You could do that same thing. These are the same expressions. So the natural log of 2 can move. Can that be simplified? Natural log of 2 roots of 2. Right? All right, we try the last one. It's our last example for the day. Tomorrow we will simply just do example 3 and 4. It'll go pretty short in class, and you'll have the rest of the time to work in class on this assignment and the short one you get tomorrow. I think that there's many ways to do these problems, but most students consistently would choose to distribute the 3 here. You get 3 times the natural log of x plus 1 plus 3 times the natural log of x plus 2 minus 6 natural log of y. After I've distributed it, what will I do then? Move the thingy up. Yep. We use such great mathematical terms. I love it. Okay, the thingy moved up. So I've got the natural log of x plus 1 to the third plus the natural log of x plus 2 to the third minus the natural log of y to the sixth. Now what? The cube was in front. We moved it up. So you're right. That would be a legal move, but that would be kind of undoing what we just did. Natural log of x plus 1 to the third times x plus 2 to the third over y to the sixth. So we'll use our multiplication division properties in conjunction with the addition subtraction to write it like that. Your assignment, please make sure that you show your work on this assignment. They are all odd, so you can check your answers, but please show your work. If it's just a one-step problem, then fine. But if there's more than one step, show your work so I know you're not just writing down what's in the back of the book. Short lesson tomorrow, lots of work time tomorrow. Have a good day.